information about where I am from, share. A company with around 60% R&D force that we have the roots from 2010. A lot of partners here from 2010. And also we established our company when the R&D could be put into production since 2016. And we're so happy and excited to share with you that we are the DJI Enterprise partner, and you can find our products in their DJI official website. So from 2020, we become the official partners that time. And till today, we are really happy to share with you that we already have around 70, which is 70, market share in China. And internationally, we have more than 50 special partners as our network. And also with a lot of end user supporting, we have more than 7,500 users already, which makes us to have a lot of applications. But I am wondering that why a lot of users choosing the 5-lens oblique camera. So maybe it's kind of interesting here as well. A 5-lens oblique camera means that it is one camera cost from Nvidia, which is in the picture and the model in my hand as well. One Nvidia and all the other 4 cameras are surrounding in a surrounding way in 45 degrees, which means that you can fly one time and capture 5 different photos automatically from during the flying. And also with our technology, we can capture 5 different photos, which means the coordinates will be written into the photos directly during the flying, which is really save our time. And also, in nowadays, we have a lot of buildings and different areas that we not only need the model from the overhead view, but also we need to capture some more information like here, like a little bit slightly under the roof, the down part. So we need to capture the data from more perspective and within limited time. Especially like in Singapore, it's really hard to have the flight get the permission to fly. And also, when we get the permission, it will be very, very limited time. So which means why we need more, we need to capture as much data as we can in limited time. So now the 5-lens oblique camera is needed during this time. And these are kind of results we captured during the air triangulation. So that is the theory that we captured from different angles. And also I would like to remind that the 5 photos, we do not share one post data. The 5 photos will have their own data separately. So it is more accurate here as well. But so after the brief introduction here, maybe some of the users will try to be curious about what applications can we use it. So based on more than 7,500 users' feedback, I made a small brief introduction here. This model is a really big area. It's around this area is around 60 square kilometer. And it is related to smart city, smart traffic, and public safety. A lot of areas related, especially for this kind of building during the planning, and also the traffic when we do the planning. But also, nowadays there are a lot of more and more interchanges as well. So we have to try to plan the traffic. A lot of areas needed here. So we capture the GSD around 3 centimeter at flight height of 319 meters. So it is taken around 5 days that time to capture the data only. And if you want to know some more information about this exactly project, you can come to our booth G13 for the very detailed information as well. We have the raw data there to show you directly. And also, after knowing the very large scale of it, we can focus on some small area like the construction site, the community design as well. So from before we decide to build a building or community in the land, we have to do a rough surveying about have a 3D model to analyze, to settle it. So during the planning and also during the construction, we need to use the data foundation to use it as a beam, with a beam information in the construction site. And also after finish that, we have to double check the data we captured. It is consistent with the drawing that we planned in the first place. So we have to do the double check as well. And also, after when we finish the whole project, after we use a long time, we need to do the inspection of the exhibition center or some other building like here, and also a community. We have to do the regularly check as well. So during all the areas, we can use the oblique camera to do the inspection and 3D modeling here. It's kind of long here. By the way, so related to the beam area, we can do the progress management as well to have the calculation that maybe after 1 month we have to finish until this point, and we can do a 3D surveying to make sure that, if we reach this part or not. So this kind of progressing management and control will be needed as well. And after this part, I would like to mention that there are a lot of coastal port in Southeast Asia because it's really near to the Pacific Sea here. And for this kind of area, every day there are a lot of ships getting in and out. So we have to make sure that the anchorage will be safe to let the ships be fixed into the, by the side. We have to make sure everything is safe. So regularly we have to do the inspection for this area, and also there are a lot of containers in the ship, but also we do not only have the containers, we have some loose cargoes like the coal, like the sand, right? So we have to calculate the volume that we shipped here. Is it legal or not? Or is it far beyond what we can afford? So we need to do the calculation. And also, we have to calculate, we have to stop by the coals here, especially in winter and summer. The angle is kind of different because of the temperature. Although it's not a lot of difference in Singapore because it's really hot recently. Yeah. And also, this is an example about the mining here as well, because we saw it just now, so this one is only a picture. And so this kind of mining, before we decide if we're going to dig the mining, we have to analyze that for the features like the color, like the 3D surveying, to see that if it is deserved a lot of labor to dig it for the analysis. And during the digging, we have to make sure that the special vehicle here in the mining, is it safe, or how much we already dig, how much left. And after digging, we have to calculate we already digged how much. Is it consistent with what we planned? And also, we have our liability to protect the environment. So we have to calculate how much grass, how much solid, we have to put it back. Let all the environment be back to normal and be safe to us. So before, during, and after could be used here as well. And also, after this full paragraph about management, there are a lot of topics related to management. Because of the time limited, I will talk with you some other information about inspection. So this is a depth part, very typical for us to see the detailed information here. So we not only need to keep an eye on the bridge, but also a little bit under here. We have to see that if there are some cracks here to make sure it is not leaking, to make it safe. And this area we fly, it's only around 3 hours 40 minutes, and we captured 1.5 centimeter GSD. And the best part with our micro photogrammetry, because our gimbal could be moved directly, and we can let the camera facing directly into the very near close distance shooting. So the best part we got is a 5mm GSD for this one. There's a lot of stuff here, so I have to put it back. And after this part, and also after we get all of this data, it's very helpful for us to make the decision if we need to rebuild or if we need to maintain this dam to make sure it's safe. And also, not only for dam, but also for the road, the highway, the road, railway, and all the information that we need to do the inspection part, especially the interchange is in the modern city is really more and more nowadays. So we have to make sure all parts of the bridge, such as the roadways, the bridges and tunnels, and all the detailed information, and including the protection part, is it safe or not? So we have to do the inspection. This one is using our Share 100 Pro, which is 102 megapixel single lens to support us to do this kind of inspection. And also, there's a real problem. It's really headache that it's a kind of funny, and I think I can share with you here, because when we have a lot of green energy related to the wind turbine, and we have to report it to say that, oh, this wind turbine, there's something wrong with it, we have to stop it, right? But if we report to the authority, to the government, and it will be kind of like, do you have some proof to show that there's some crack in the turbine? Because, stop all of the wind turbine is really a lot of cost. So our Share 100 Pro could support the non-stop inspection of the wind turbine. So you can prove some rough information to say that, oh, there's something wrong with the number 4 turbine. Because all of our photos that we took will be with coordinates. So we will know exactly this is number 4. This fan has something wrong and we have to stop it exactly. So which help us to do the non-stop in advance. And then we can stop the turbine to report in detailed information. Similar idea with the solar panel as well, because the solar panel is kind of, when we see it in the vision, it's kind of like all the same, so we cannot tell which one is it. So we can use the photo with coordinates to say, oh, number 100, there's something wrong with it. We have to check it exactly to save our time and labor cost. And not only for this part that is really related to your life, daily life, like the energy, like the road, all the information, but this one, we do not want it to happen. But this one, we have to do something, avoid it happen. Like the rock, we have to analyze that the rock is landslide or mudslide. If it is, we need all the features like the color, like the 3D model, all of it, and to analyze if it is not safe. We have to calculate how much volume we need to put the protection to protect this side exactly. Just avoid let the rock get outside to hurt some people. So we will need a real 3D model, not the colorized one. We need a real model with the post information exactly. And after this part, it's kind of, this one is, we try to protect something that we use daily, but these are from our ancestors. This is an example from China. The really ancient building. We have to protect it. And also, I want to show an example which is maybe not very suitable, like from the Palace Museum, the tower in the Paris, I mean. So it is ruined, kind of. So if we have the very tiny model of it, we can fix it after the fire, which is really helpful. If there's something wrong because of the main force that we cannot avoid, we can use it to fix it directly to protect our heritage. And also after that, we could do nowadays there are a lot of movies or games which need a real sense. But we do not, the disaster movies is kind of popular recently. We cannot bomb the city directly. We can use a model to stimulate it. So this one is helpful in games and also in the movies here. this is only a very short part of the applications. We have still a lot of more applications, like more than 35 applications from all the users' feedback. But because of the time is limited here, we can only share with you this much. If you want to know more information about the applications of our uplink camera, just come to visit our booth at G13. And any question is welcome. Thank you for your time.